So here's a question from the JEE Advanced 2021 Physics Paper 1. And it says that there are 2 point charges, negative q and positive q over square root of 3. And they are placed in the xy plane at the origin and at the point 2, 0. So this point right here, its x coordinate is 2, as shown in the figure. This results in an equipotential circle of radius r and potential v equal to 0 in the xy plane with its center at b, 0. So the circle has a center at b, 0, and its radius is r. And the potential on all the points in this circle, the potential is equal to 0. All the lengths are measured in meters. So what is the value of r and the value of b? So let's try this question. Whenever we have an equipotential surface, we automatically can just write a few equations around at various points and then figure out these distances. So let us take two really simple points. Let us take one point here and let us take the other here. So this point right here on the left side, this is at a distance of b minus r. This entire distance from here to the center is b. The radius is r. So this distance is b minus r. And the other extreme point is at a distance of b plus r. Now, let us name these points as a and b. Now, the potential at a, since the entire circle is an equipotential surface, the potential at a is equal to 0. And that can be written as the potential at a due to the charge negative q plus potential at a due to the charge q over square root of 3. And similarly, we can do the same thing for b as well. We can write b minus q plus potential at b due to q by square root of 3, and that is equal to 0. Now, due to any point charge, the potential at a point that is at a distance r away from the charge, let's say that this is the charge small q, then the potential at this point due to charge q, small q, is equal to q over 4 pi epsilon naught r, where r is the distance. So we can take this fact and put it in the first equation. In the first case, with the potential at a due to negative q, this first term is going to be negative q divided by 4 pi epsilon naught times the distance is b minus r. This. And now we write the potential due to the charge q by square root of 3. So we write the charge q by square root of 3 divided by 4 pi epsilon naught. And the distance here now, this distance is 2 minus b minus r. And this is equal to 2 plus r minus b. So we just write that around here, and this is equal to 0. We do the same thing for this equation as well. So at the point b, so again, negative q divided by 4 pi epsilon naught, and then the distance from this charge to b is equal to b plus r. And the distance from the point q by square root of 3, well, that is equal to, this distance is equal to b plus r minus 2. So 4 pi epsilon naught b plus r minus 2, and this is equal to 0. Now we just need to solve these two equations. We can right away cancel the q's since they are common, and we can also cancel the 4 pi epsilon naughts since they are common as well. And once you do that, you get 1 by square root of 3 r plus 2 minus b minus 1 by b minus r, that is equal to 0. And the other equation, let's write this term first, 1 by square root of 3 b plus r minus 2 minus 1 over b plus r is equal to 0. From the first equation, we can write that square root of 3, or let me use a brighter color for this, we can write square root of 3 times r plus 2 minus b is equal to b minus r, since we can, both of them are in the denominator, and we can take them to be equal. And similarly for this as well. So there are two equations and there are two unknowns. We can easily solve these. So we first add these two equations together. That then would give us square root of 3 is common, and these will cancel out, and so that will give us 2r, and this is equal to, well, 2b. So we get b is equal to square root of 3r, and now we just use this and we just put it again, back again. So this will give us square root of 3 r minus square root of 3 plus 2. Instead of b, we just write square root of 3. And this is equal to square root of 3 minus 1 r. And now, again, this is just a messy calculation, nothing more. So this is square root of 3r minus 3r plus 2 square root of 3 is equal to square root of 3r minus r. And this gives us, these cancel out, and so 2r is equal to 2 square root of 3, and the value of r comes out to be equal to square root of 3. Once that is done, we can just put it back in this equation, and that gives us b is equal to 3. So I guess those were the two questions that we had to answer. The value of r, the radius of this equipotential circle, that comes out to be square root of 3, and I guess the answer had to be done in 2 decimal places, so that would be 1.73. And the value of b, the x-coordinate, the abscissa of the center of this circle, well, that is 3.00.